All right, Algebra, Chapter 6, Section 4. We're looking at exponential functions. The last time we looked at functions, we were looking at linear functions and graphing lines. And if you remember right, we would make a table. Let me get something like this. Let me get this polished up and I'll bring it back to you. Okay, and we would have something like this. Just a quick little table. We'd have x values and y values, and I'll just give really basic ones. Let's say that was 1, 2, 3, and 4. And then this was 6, 7, 8, and 9. Remember that linear functions were going to go up or down in the same amount. Okay, so this one would be linear. And that's not going to let me write over there, so I'm not even going to try. I'm having some trouble with that half. So this one would be linear. Okay, so now let's take that same process and let's see what an exponential function is going to look like. Again, exponential just meaning exponents, which is what we've been dealing a lot with. Let me extend this page a little bit. Maybe. Something wrong with the middle of my board. Okay, so let's take a look at an exponential function. So in this case, I go up and this is example B on page 302 out of the text. And I go up to the top one and I do see that those are increasing each time. So that's still increasing by 1. And so currently it's linear. But when we go down to the bottom, if I go from 4 to 8, I add 4. If I go from 8 to 16, I add 8. So I know that's not what I'm doing. What I'm actually doing is I'm multiplying by 2 in each case. Now, each one of them is being multiplied by the same value, and that's what it has to do. It does still have to remain constant. However, it could be multiplied or divided by a constant instead of just adding or subtracting. So in this case, this is an exponential function. So that's the difference between linear functions and exponential functions. Linear functions add or subtract at a constant, and exponential functions are going to have multiplication or division of some sort. So now let's take a look at evaluating exponential functions. So remember when we were linear, it was y equals mx plus b, etc. So in this case, it's going to be the same, just look a little bit different. So we're going to start with y equals -2. Okay, y equals -2 times 5 to the x power. And in this case, they're going to give you the x, and I believe that this is x equals 3. So all we're going to do is substitute in things and use our exponent knowledge that we've gained at the beginning of this chapter. So that's going to be y equals -2 times 5, and I'm going to substitute that 3 in there everywhere I see an x. Now we have to ask ourselves, we have multiplication, the -2 times the 5, and we have an exponent. So let's go back to order of operations, and that order of operations says that I do parentheses first and then exponents. So in this case, I'm going to take my 5 to the 3rd power, and that's going to give me 125. And when I multiply that times 125, when I multiply -2 times 125, I'll get that out eventually, and that's going to end up being -250. So again, just solving some exponential functions, plugging that in. So let's look at telling whether something as just identifying an exponential function. The actual setup or the formula for exponential function looks something like this. Not something like this, it looks exactly like this. Sorry. It is y equals ab to the x power. And again, that x has to be unknown. It can't be constant. I can't just say it's 3. So let's look at some examples. If I had y equals x, not x, 5 to the x power. Okay. My 5, that's what's been subbed in for AB. And my x is unknown, which means it can be variable, and it's not going to be constant. And so this is an exponential function. I could take that a step further, and I could multiply a couple of things. So I have an a and a b. And again, my exponent is variable. It's an x, so I don't know exactly what it is. Now I keep saying it's a variable. What if it looked like this? What if I did y equals 5x to the third power? So in this case, I know what my variable is. It's 3, which means it's not going to change. It is not variable. It's constant. And that makes this not an exponential function because I have a set, a predetermined exponent, and that is not possible. Now, one more thing. The a and the b both have to be positive. And so if I were to get something like that, a, b have to be constant and positive. And so in this case, because our b is negative, that makes this not an exponential function. Okay, so I'm actually going to take a look at numbers 21 through 24 in the text, and I'm going to do one of them. I'm going to go ahead and look at number 23. And what I'm going to do is I'm actually going to graph it and see which one it matches up with and show you what a graph of an exponential function looks like. As soon as my boy, there we go. All right. So number 22, it's y equals 2 times 2 to the x power. And I'm going to stay over here because I know the right side isn't working very well. Okay, so our x is variable. And so what I'm going to do is I'm just going to make a table, and I'm going to give some x values. And then we're going to plug it in and see what our y values are. I'm going to make it a vertical table instead of a horizontal table. And so I'm going to stay with some positive values, and then we'll go here in a minute and possibly put a negative value in there. So I'm going to just go with 0 and 1 and 2. If I plug 0 in there, that's 2 times 2 to the 0 power. 2 to the 0 power is 1, and 1 times 2 is 2. Again, just substituting those values in. The second one, 2 to the first power, that's going to be 2 times 2 is 4. And then the third one, 2 to the second power is 4. 4 times 2 is 8. And so this is what my graph is doing so far. It's at 0, 2. It's at 1, 4. And it's at 2, 8. Okay, now I can go ahead and look at those graphs and I can tell which one it is already because this is a multiple choice question. But I want to go ahead and throw a -1 in there, and I want to throw a -2 just because we've been working on these properties and we should be able to take exponents to the negative power. So 2 to the -1 power, that's going to be 2 to the -1 over 1, and then I flip it, so that's going to end up being 1/2. And you can probably see what the next one is going to be when I take it to the -2 power. That's going to be 2 to the -2 power. I flip it, it's 1 over 2 squared. And so, I'm sorry. I forgot to multiply that by 2. So that was 1/2 times 2, which is going to give me a value of 1. That was terrible of me. Sorry about that. All right, to the negative 2 power, that's 1/4. So I'm going to have 2 times 1/4, which is going to give me 1/2. There's my 1/2. Okay, so that's going to be negative 1, 1. And that's going to be negative 2, 1/2. So what this will actually do is it will look something like this. And it will never actually touch the x-axis. And so if we're looking at that multiple choice, that is going to be choice A. It will approach it, but never touch it. So again, just graph the other 3 and substitute in those values. I would use the same ones, 0, 1, 2, negative 1, and negative 2, and get the values, match them up with A, B, or C. A little over 11 minutes. That is 6-4 exponential functions.